module 3. Consider the function fact n defined as int result is equal to 1 and other stuff. For I is equal to n, I is greater than or equal to 1, I minus end result is equal to result multiplied by I, return result. So this is going to look for whatever amount of time that we say to run it for, which is n. Take the values of I, n, and result at the beginning of each iteration of the function if 4 is invoked. Okay, so it'll be like I, n, and result. I'll just put like that. Yeah, I, n, and result. So there's nothing that says that you can't put a table inside where the lines are. If you put a table, nobody will get back to you. Alright, at the beginning of each iteration, so when this for loop starts, I will be equal to 4, n will be equal to 4, and result will be equal to I multiplied by 4, which is 4 by 4, which is 16. Then when the loop goes, it goes to I minus, so I will change to 3, and then n will stay as 4 and never change, and then 3 4s are 12. Then the I minus will carry it down by 1, so it goes down to 2. N stays at 4, that never changes. Nope, sorry, result is not 12, result is 16 multiplied by I, so 16 by 3 is how much? 48? 32. 3, yeah, 48, right? Yeah, 32 multiplied. Alright, and then we loop one more time. The I goes down to 2, so 48 by 2 will be 96. And then the I goes down to 1 because of the I minus. The 4 stays the same. 96 by 1 will be 96. And that's it. The I will never reach down to 0 because the condition is I must be greater than or equal to 1. So that's where you should get there. Say the values of I and n at the beginning of each iteration of the function. At the beginning of each iteration. So let's say at the beginning of iteration 1, result is 1. At the beginning of the next iteration, no, I starts up at 4. Right? Yeah, this I don't like. Okay, understand now. Understand why I kind of misinterpreted. So they wanted at the beginning of each iteration, not at the end. So the beginning of each iteration, n will be 4, I would be 4, result would be 1. At the next iteration, n would be 4 still, and not changing. I would have gone down to 3, and result would be 4. And then 4 by 3 would be 12, and 12 by 2 would be 24. Alright, yeah, that's it. What did they say about this? Yeah. Alright, yeah, so the results had to start off at 1. You are correct. Okay. The function fact n can be represented as n factorial, right? The function chooses the name of the function. Int n is the parameters, and n and r are the parameters that being passed it, or the arguments. And r, and returns the value equal to that. Okay, now this here is not the simplest of tasks, but you have to, if you have a mathematical brain, you should be able to follow through. So it's receiving an int and an int r. They gave us that already, right? So we want to represent fact n is the same thing as n factorial, well, n exclamation mark, for those of you who don't know the math. So what that means is every time you see n exclamation mark, you have to replace it with the word fact n. So fact, and I'll replace this first part here, and then we have nr factorial. So what you're doing is you're dividing it by fact, but inside you're gonna put n minus r as the substitution for what n is, and then that is being multiplied by r. So returning an integer, we have to. Then you probably have to declare integer. So you have to declare like in answer, and then say answer is equal to that, and then return answer. Right, that's the trick to that. Because, well, normally in maths, when you have two things next to each other, like if you have x, y, that's x multiplied by y. So you have this part here is next to the nr with the exclamation mark. That will be replaced by fact n minus r, and then obviously between the two of them a multiplication sign has to be assumed. Now it have an exclamation mark at the end of it. If fact n is n with an exclamation mark, that means whatever comes before the exclamation mark is what you're putting inside the bracket. You understand? Okay, if you say n exclamation mark, that basically means you have to say n, right? So the n here is what goes inside the bracket. If you say r exclamation mark, is the same thing that you're saying r, because r is the thing that's being calculated. Whatever comes before the exclamation mark, that's what you put inside the bracket. Yeah, because it's always the same function here. Alright. Part B now, explain how the assembly and linking process allows code written in high-level programming languages to run on a wide range of machines. Okay. Assembly language on the the source code into a form that the processor can understand. Linking would connect that code to all the libraries necessary for that program to run. Example, a mouse or keyboard. Yep. Okay. Alright, so assembly language breaks down the source code into a form that the processor can understand. Linking connects the code to all the libraries necessary for the program to run. Example, a mouse or a keyboard would be linked to it. Alright, so that's good. Next, the following data structure has been defined in C to support an environmental and monitoring application. Here is where the air gets rare. So we have some integers, which is number of months is 12, number of locations 20, and name length is 20. Each one of those is an integer and number. Then we create a structure that creates a character, a character string, which is location name, and then our readings, which is number of months. So this structure, if we were to draw it out, would have two shelves. One shelf will be for this, but the name is actually a bunch of spaces like this, right? 20 spaces here, and then the number of months is just one. Is an array with 12 spaces. So that's I'm gonna draw it all 20. That you can kind of see. But if you don't draw this question, it's get real difficult. Drawing it out is the only way that I know that will make it easy for people to understand. So name length, the number for name length is 20. So we have to have 20 spaces there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, so that's the 20 spaces for the location name. And then we have readings, which is number of months, which is 12. So we have to put 12 spaces here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, so inside there, you're basically holding a name of something, and then you have 12 numbers that you want to keep track of. So this is technically a name. And the name of the structure now is now called Caribbean history with number of locations. So now you have a bunch of these, a bunch of these stacked up next to each other. Right. How much of them do you have? Number of locations is 20. So you have 20. So this would be location 0, location 1, location 2, location 3. Right. So this is the actual structure called the Caribbean history structure. And the structure is now represented by an array. A bunch of the structures now put in a bunch of structures put next to each other, which would be an array of structures. So this is Carib history location 0, Carib history location 1, Carib history location 2, Carib history location 3. That's the introduction there. Does that make sense?
Yes, sir.
Anything else? Alright, good. So now they tell us that a supporting module to the environmental monitoring application has been populated. The data structure Carib history with monthly average readings of the sea temperature of different locations in the Caribbean. So they put in monthly average readings of the sea temperature inside each one of the structures. The data population process indicates any erroneous reading by storing a flag value of -1 in that location. So what that means is, what is going to happen is in any one of these structures, if we were to zoom out of it, we have a structure that looks like this, and they put in 12 numbers, because those are the readings, right? So they could put any numbers that they want inside here, and numbers that they put inside could be like 5, 9, 20, 31, 16. But if there is a bad reading, they'll put in a -1, and then there'll be a 12, and then there'll be a 10, and then there'll be a 9, and there'll be a 2, and it could have a next -1, and it could have a 7. Make sense so far? What if it repeating it? Okay, so every one of the structures for Carib history is going to have two things in it. It's going to have a name on top, and then it's going to have a reading. But you have to remember, a name in C is an array. So a name is a string, and a string is an array. So they'll have a name inside here. What name it's gonna have inside here? It could be wherever they want to put inside here, but it must be less than 20 characters in length. At the bottom, however, they have readings, and the readings would be an array of numbers, and the array of numbers is represented by an integer, but they tell you how much numbers to put in the structure, which is 12. So those 12 spaces, each one of them represents a month. So each time they get an average reading, they put it inside the structure like that. But if they get a bad reading, they will have a -1 at that location. Okay, so now they ask, write a C module, aka a function, num readings int island index, that returns the number of valid readings for a location specified by an index. So they're giving us the island index. Now the reason why they're giving us our island index is because you see this thing num locations here, number of locations. These are the number of islands that we have. So that means each island is represented by a number. So each island, there will be one island that is island 0, then there'll be island 1, then be island 2, then be island 3. And we're going to get that information sent to the function by island index. So we're going to put in num reading int island index. Alright, so watch. They're giving us the island, they're giving us the location that they want us to check. All we have to do is get to the location and then check inside here. We need to check inside here for the 10 things that for the, well, each one of the 12 months to return the number of valid readings. So we're checking through all the readings and we're checking to see if we get a -1 or you don't get a -1. So our job is to loop through one structure based on the index. So we're going to put carib history. No, we had to do a for loop, sorry. We had to set a int c is equal to 0. And we're going to say for c is equal to 0. C less than 12 because we want to loop through the bottom part of the structure. Well, where we're trying to loop through right now is here. We are trying to loop through these numbers here. So if we're looping through those numbers, what we're doing is we're going C is equal to 0, C less than 12. And once you do that, you set up the ability to go through 12 times. Now when you go through 12 times, what do you want to go through? You want to go through if Arab history location, what they're looking for, island index is equal to -1. We would want to keep track of that. So we could say flag plus, right? That means we found a -1. So we have to create a variable for flag. Flag is equal to 0. So far we found no flag. But if you go through all of them and you find a flag, then what you want to do is note it. And they asked, what did they ask us for? They asked us to return the number of valid readings. So then we could say valid, after the whole for loop is finished, we could say valid is equal to valid minus flag or flag. So we would, in that case, we'd have to set valid as 12. Valid is equal to 12. So we automatically assuming that we have 12 valid months, but we're going to go through all of the spaces inside that particular structure for this island index, whatever island index they give us. And we're going to look for all the -1s. Every time we find a -1, you carry up flag by 1. Once you carry up flag by 1, then you'll get a total amount of the -1s that you met. And then you could subtract that from valid, which we set to 12, to know how much valid we have. And it's supposed to return. So it's supposed to return valid. So we're just going to put now return valid. And that causes that. Alright, how you feel about that? Is it one of those moments where somehow when you explain it, it makes sense, but when I was reading it, it wasn't making any sense?
Yes, sir.
Yeah, boy, those moments in life, trust me, the first time I read this question, I was like, whoa! Yeah, right, so that makes sense. Imagine you only getting 4 marks for that. So, this will be readings. Dot readings. Location C equal -1. Right, yes, that is correct. Because you have to go into the structure. This will get you into the particular structure, and this will get you to be able to iterate through all of the locations. Alright, so that is the fix there. Cool. But let's move on now. Right, a C module now, which is a function, average temp, you put that on one time, average temp in island index, right, that evaluates the average temperature of a location for which the index is specified. It ignores any erroneous readings and returns the value as a floating point number. So if we return it as a float, then we have to declare this as a float. Did I put int here before? I had to put int in front here, right? So it declares it as a float and returns the value as a floating point number. Okay, cool. So we want to go through the average temperature of a location for which the index is specified. So they're giving us the island index again, and we want to find the average temperature, but ignore erroneous values. So we're doing the for loop again. We'll set up our C is equal to 0. I'm going to say for C is equal to 0, C less than 12, C plus plus, right? That means we're going through all 12 locations. Each time we go through a location, we're going to check to see, we're going to find the average, right? So we have to create a sum is equal to 0. If, what's the name of this place again? Carib history. If carib history location island index is equal to, oh no, not equal to -1. I put not equal to -1 for this condition. Not equal to -1. Then we're going to say sum is equal to sum plus Arab history location island. Basically means add whatever value you get there, as long as it's at -1. And then we'll say we'll create a count because we have to find the average at the end. So I'll create in a second count just because I have to divide by count. And I can't use C because C will end up being 12. Well, C will end up being 11, and I don't want to mix it up. So if that is the case, find the location and we'll carry up the count. And then now we're going to say average. I'll create a float for average, load average. I'll say average is equal to sum divided by count, and then return average. How much marks are getting for this? 5 marks for this one. Right. So the logic is I am getting the island index from whoever is calling the function, they send in the island index, right? I have to create a variable for average as a float because it has to return a floating point number. Creating a for loop, I need the C, I need to find the sum, and I need to find the count, and well, I have the average. So for C is 0 to 12, that means I'm going through the location of the structure, which is location 1, then 2, then 3, then 4, then 5, then 6, all the way up to 12. Right. Every time I bounce up anything other than -1, because -1 means it's a bad recording. If I don't get a -1, if I don't get a -1, sorry, I find the sum of that particular location and add it to sum, and then count plus, and I say average is equal to sum divided by count, and that's it. I should have closed the for loop. I had to close the for loop here. For loop has to close here before you return, because you can return under a for loop. You can return any for loop, that will basically break it. Cool. Does that make sense?
Yes, sir.
Right. Now, write a main function, aka write the main of the program that iterates over all records in the structure carib history. So that means we're not just looking at an individual record anymore. We're looking at location 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up to 20, because we have 20 locations available. So we had to get a loop that's going to go 20 times to go through each location and print a report with the location name. Remember, the location name is the first part of the structure, followed by the average if the data set for the location is considered valid. Hold on, I think I make a mistake. The data population process indicates any you are trying to evaluate the average temperature of a location and ignores any erroneous reading. So anytime you see a -1, you should ignore it. So let me update this one time, because what I would have to do is I would have to do carib history island index dot numbers dot reading location C is not equal to -1. Yeah, carib history in dot reading C. You are trying to evaluate the average temperature of a location and ignores any erroneous reading. So anytime you see a -1, you should ignore it. So let me update this one time, because what I would have to do is I would have to do carib history island index dot numbers dot readings location C is not equal to -1. Yeah, carib history in index dot readings C. Right. Yeah. Otherwise, a message is saying that the data set is invalid, should be printed. A data set is considered valid if less than half of the readings are erroneous. Now, you have to use the previous functions that you use, so you should use the function num readings and average temp. This one name is average temp? Yeah, average temp. And average temp to do your calculation. So basically, you get to use back the functions that you created, provided that you're doing the correct thing. So assume that all locations are terminated at the end of string character. That basically means that everything is a character in the area structure. So we're going to create a main, void main, and our main is going to do the following. We need to loop over all 20. So we have to get some variables inside here. Do we have to get any variables? We have to get a counter at least. C is equal to 0. Int C. And then we're going to say for C is equal to 0, C less than 20, C plus plus, right? Because we know we have to do it 20 times. But this time we are looping through every single one of the array of structures. So we have to check now to see, we have to call the num readings function, so num reading, and we are sending to num readings, we're sending C, because C would be the first location, it would be location 0 in the area of structures. We can remember the area of structures set up something like this, right? There's a bunch of boxes. Inside it has a name like Barbados, and inside Barbados has 12 different readings, but Barbados actually will be location 0. Location 1 will be like Antigua, and they have 12 different readings inside here. So what I'm trying to do is I'm trying to focus on this place, do something, then loop, focus on this one, do something, loop again, focus on this one, do something, loop again, focus on that one, do something. That's the whole point of the loop. So what I'm doing is I'm calling num reading C. The reason I'm calling num reading C is because I wanted to return the amount of invalid places that it has. So I will say, what does num readings return for me? Well, num readings returns the number of valid readings. Okay, so I'll create an int C and an int valid, and I could say valid is equal to num reading. There, valid will be equal to num reading. Okay, right. So I'll say valid is equal to num readings, and then I have to say if valid is greater than, says a data set is considered biased, less than half of the recordings are erroneous. So less than half are erroneous. So that means if valid is greater than or equal to 6, we say greater than 5. Right? So because it says less than half is 5. So if you get the amount of valid things as greater than 5, that means it's 6 and up. Yeah, if less than half, it's considered valid if less than half of the readings are erroneous. Yeah, if valid is greater than 5, if valid greater than 6, well, if valid is greater than 6, that means it will be 7, 8, 9, or how do we greater than 5? 6 and up here. So you have to have 6 and up here. So if valid is greater than 5, then you do your calculation, which is to print out the report. So if valid is greater than 5, what do I want to do? I want to the location name followed by the average if the data. I try to calculate the average now, so I'll call the, if valid is greater than 5, I could do the average temp. No, I'll call the average temp and put it in a variable. Okay, I'll call that average. Average is a float. Average is a float. I need to put float average, and then I'm going to say avg is equal to avg temp, and I'm sending C, because C is the location that I'm currently on. And then after I do that, I want to print out stuff. So I want to print f location, and the location is going to be Carib history CARIB history location C. That'll be the location, and then I want to print f the average, a location percent f. I have to put the percent s because it's a string of printing now. Percent s, and then this one is print f average percent D, and I'm printing out AVG, right? Which is the average I just calculated inside here by calling. Once I call the function here, average temp, it will store the average for that particular location. And then I now have to redo the else now, which is else printer. I don't want to print data set invalid, and then end before the open bracket. Here, does it meet all the requirements? It meets the requirements because let's see, I have the average to calculate the average inside here. I have valid and I have integer, right? So the 4 is less than 20, cool, no problem. I call in the num readings function. The num reading function will put a number inside valid that tell me how much valid readings I get. If the amount of valid readings I get is more than 5, that means it's acceptable. So I will call the average temp function by sending C, because C is the index of the location that we're working on at that point in time, which will be location 0 at the start. Put that inside average, and then I'm printing out the location, which is Carib history C dot name. I had to put dot name, dot location name. Wow, that's a lot to write in that space there. Alright, this is supposed to be Carib history location C dot location name 459. Okay, I could pull the whole thing back a little 3,000 or something. This is really hard to write in one. I have to put in here dot location name. Yeah, because if I don't put that location name, then the location which will be stored, the variable for location name will be separated, which is a string here. Alright, and then we print out the average, which is the average that we got when we call the average function. Else printf data set is invalid. I didn't put any opening and closing brackets for the with this else here because it's one thing that's being printed, and also we'll have a problem because we don't have enough space to write it. Right, so that's the answer for 6 marks. Very, very, very good. It's a lot for that 6 marks. Are you dead yet, or are you alive? Any questions about the logic? What's that? I'm not hearing it properly now. But do you understand my explanation? Okay, now that you're alive. Cool. Alright, now for some, nicer questions. List two ways in which good programming style can be maintained and explain why each is important. Oh, we could do this. You could use white space and indentation. Okay. White space is separate a different line in the program, making it more readable. Indentation to separate the control structure that is more logical, flow, and see. Okay, 3 stages in the translation process. So there's lexical, syntactic, code generation. Alright, lexical, syntactic, and code generation. Any 3 could work. There's also code optimization. Looks my question. Write a C function which accepts an integer array and an integer variable indicating the size of the array. The function should return the location of the maximum value in the array. Int, it receives an integer array in ARR and size inside. Right, the function begins. We want to return the location of the maximum value, so we have to put a variable for max. Int mark it as 0, and we need a counter because we're gonna loop through the whole thing, because we looping through the array to find the highest value. So 4 c is equal to 0, c less than is equal to less than max, c++. That will carry us up by 1 each time. What do we want to do? We want to check to see if ARR location c is greater than max, then we're going to set max ARR location c. Alright, so we'll update the max, but they want the location. All they want to look at, they don't want the actual maximum value, just want the location. Yeah, so if it's just the location, we can just keep track it by saying location is equal to c. Take the c and put it inside location, and we should be good. The for loop is finished there. Alright, that's part C. Look at lines for this one. Let's spare some other lines for the other one. Alright, a courier company operates in a certain country and charges a fixed fee for delivers package as well as a variable fee of £5 per pound based on the weight of each package. The company operates in 4 zones and the associated fixed fees are as follows. Each customer is assigned an ID that consists of a letter corresponding to the zone and a 5-digit number. Example S125577. That would be so. Right, the function that returns a flat fee. Alright, so if it returns, it has to be a float. So we want to get the customer ID and return the flat fee to be charged. Okay, so when you get the customer ID, remember you're getting a string. So this question is testing to see if you know how to manipulate strings. So we'll ask them to enter the ID, enter ID. Then we could scan a cent D, and we're reading that into what? And ID. No, the ID is not an integer, it's a string. Char ID 25. Right, so we scan the ID, and now we have to check to see what the first letter is. Okay, now we have to check to see which zone they're from. So if ID location 0 is equal to n, if it's equal to n, then the fee is equal to 30, and then we say if ID location, no, we're still looking at location 0, if it's equal to what's after n, fee is equal to what? If location 0 is equal to after south is if it's equal to, we guessed it, south, north, south, and then fee is equal to 55. Last one now is if ID location 0. What happened? Odd reason up in location 0 because I want to compare the first letter of the ID right here. That's right, is equal to W. What do I do with the W? I will say fee equal to 70. And from there now, right, to get the customer ID, return the flat fee to be charged. Yes, so when that's done, we just go down and say return fee, No for loop, nothing. You're just getting one ID and checking to see if over. Next, write a C function that accepts a customer ID and the weight of the package and returns the delivery fee. Use your function from part 1. Alright, so I could use this function and call float total. Total should be a float itself. Right, so float total. And we want to get the flat fee. So I'll say float flat, and then we want to say flat is equal to the function I just created. So get zone fee. So flat is get zone fee. And what do we have to give them? Nothing. Oh yeah, to put the customer ID. Oh, this function accepting the customer ID. I forgot to put that in, yes, right? In ID. No, char ID 25. Yeah. So this char ID 25 here not necessary because the function is accepting the ID. I do have to put the 25 when I'm accepting it. I can just put char ID in the square brackets will be right. And char ID. Alright, good. So what we have to do here is we have to get zone fee and send the ID of the person. So I'll change these things. So float weight. I'll put ID for sure. It accepts the customer ID, and the weight. Weight could be a decimal, so it will flow. Right. So to get the zone fee, I have to send just the ID alone. ID. So I send the customer ID. Once I send the customer ID, I will get back the I'll get back the flat rate. Yeah. Once I send the customer ID, I'll get back the flat rate. Once I get back the flat rate, I now have to calculate how much they're going to pay extra. How much extra they're going to pay. And they pay $5 per pound based on the weight of each package. Okay. So I have the flat rate, and I'll say total is equal to flat. Total will be our next variable. Total is equal to flat plus the weight of the package minus the, what's the flat rate? Oh, no, there's just a fixed flat rate fee for anything, and then any whatever weight it is, you multiply by 5. So flat plus weight multiplied by $5. That'll be the total, and return total. Okay, so let me neaten up this. I didn't give the function a name, so it had to be flow delivery. So that'll be the delivery fee is what is going to be returned. I return that by sending the ID, sending any weight. I create two variables to hold the two things that I need. Flat rate is going to be get zone, and that's the ID I have to send. And then the total is flat plus the weight multiplied by 5. And then I return in total. Okay, cool. 4 marks for that, boy. That is wicked. Any question? The only question that should be on your mind is why? Why would they do this stuff? I can imagine doing this in an exam like this. This is like not cool. But we'll figure it out. Okay, so the output generated by the following code. We have a N, a C, and a K. 4 C is equal to 1, C is less than or equal to 5, C++. Okay, good. So 4 K is equal to 1, K less than C, K++. So K starts off at 1, K less than C, C is 5, but there's 2 loops inside each other. Okay, 1K, alright, C is 5, okay. Print whatever C is, so we print in whatever C is. As all the one with the output generated. Okay, so we print in whatever C is. C is, in the first instance, we're going to print C how much times? 1 to 5 times. So we print 1, 1, 1, 1, 1. Right, that'll be the first loop because this one is going to go from 1 to 5. Then, so the inner loop will print 5 times, and then the outer loop now is going to change C to 2 to -5. So, it'll print 1, 1, 1, 1. And then C will now become 2 because of that, so it's going to print 1, 2. But C changes to 4 here now. C changes to, hold on. Let's start this over. Slow down. Okay, so the value of C here is, according to the loop on the outside, C starts off at 1. Okay, so A is equal to 1, K less than 1. So we print 1, 1. That is the first loop. On the second loop now, C is going to not be 1 anymore. C is going to be 2 because it's trying to get to 5. So now C is going to be 2. So we print in the value of C, which is 2 twice because it's 1 to 2. So we're going to be 2, 2. Then now C on its journey is trying to get to 3. So it will be 1, 2, 3. It'll be 3 times. Printing out C, 3, 3, 3. And then we could imagine it's going to go to 4 because now C is finished being 3 here. So it's going to be 4. So it's going to be 4, 4, 4, 4. And then C end up becoming 5, which is the last condition for the loop to be acceptable, which will be, I'll print out the value of C, 5, 5, 5, 5, 5. Right. That is. So I'll just let you know that by far, this is the hardest module 3 that I've ever seen throughout all of ComSci for the past, up to 2019. Yeah, this is the hardest module 3 that they ever had in terms of the amount of work you have to do for the little bit of marks I get. There are some questions that is asked you to get 2 numbers, print them and find the average, and it's 6 marks. And this question alone is 4 marks. This one here is 4 marks for writing all that in a function. This one here is 4 marks for writing all of that for the whole set of this one here, 6 marks for this, but only 4 marks for this. Yeah, it's kinda awkward.